Your Ford truck, or SUV, is rolling off the assembly line with a set of hidden factory configurations that are quietly inviting thieves to drive off with it, while simultaneously grinding your engine bearings to dust. You bought a modern machine thinking the advanced tech was working in your favor, but after 16 years of tearing these vehicles down to the frame in my shop, I am here to tell you that the manufacturer has prioritized showroom convenience over the long-term survival of your powertrain and the physical security of your driveway. They won't tell you about these vulnerabilities because doing so admits a design compromise. But today we are stripping back the software curtain. Let's start with the immediate threat sitting in your driveway tonight: the slow, silent death of your truck's perimeter security. You walk up to your F-150, you grab the door handle, and the truck seamlessly unlocks without you ever touching the key fob. This is Ford's Intelligent Access passive keyless entry system, and it relies on your key fob constantly broadcasting a low-frequency, unencrypted wake-up signal into the surrounding air. What Ford didn't account for, or chose to ignore, is that this constant electronic chatter creates a massive security blind spot. Thieves are currently using cheap, handheld relay amplifiers to capture that faint signal right through your living room wall, bouncing it directly to an accomplice standing next to your driver's door. To your truck's onboard computer, the key is physically present at the handle, allowing the thief to open the door, press the start button, and drive away in under 45 seconds without breaking a single pane of glass. Here is what the dealership network actively covered up. From roughly 2016 onward, Ford actually built a hidden deep sleep sequence directly into the key fob firmware that allowed owners to manually kill this transmission entirely. By pressing a precise cadence, lock, lock, and then holding unlock within a 3-second window, you could force the fob's internal transmitter to go completely dark, making a relay attack physically impossible because there was no signal left in the air to steal. Why don't you have this feature on your 2022 or newer model? Because dealerships were absolutely flooded with warranty claims from confused owners who accidentally put their keys to sleep, walked out to their trucks, and panicked when the proximity unlock didn't work. Rather than educating the consumer, Ford quietly wiped the manual sleep sequence from newer key fobs, opting to replace it with a motion-based internal sensor that is notoriously slow to react and highly unreliable if the keys are moved even slightly on a kitchen counter. They traded your truck's physical security for fewer service department headaches. To combat this, you need to implement a layered defense immediately. First, spend $15 on a high-density, dual-weave Faraday pouch and place your keys inside it the moment you walk through your front door. If you can stand next to your truck with the fob inside the pouch and the door still unlocks, throw that pouch in the trash because the signal shielding is defective. Second, climb into your driver's seat, navigate to your Sync touchscreen menu, and look under the vehicle security settings for a feature called the Personal Start Code, or Push-Button Start PIN. This buried setting forces anyone inside the cabin to enter a customizable numeric sequence on the screen before the powertrain control module will allow the engine to crank, effectively turning your truck into an immovable brick, even if a thief successfully executes a signal relay attack. But the hidden settings threatening your vehicle aren't just electronic. Some are mechanical time bombs disguised as eco-friendly features. I am talking about the factory-programmed auto start-stop configuration. Every single time you come to a red light or a stop sign, the engine management computer cuts fuel and spark, killing the engine to save a fraction of an ounce of gasoline. What they don't show you in the glossy brochures is what happens inside the oil galleries when that engine dies. When the crankshaft stops spinning, the mechanical oil pump ceases operation instantly, causing the pressurized hydrodynamic oil film between your crankshaft journals and your main engine bearings to collapse. Your engine components transition from hydrodynamic lubrication to boundary lubrication, meaning that when the light turns green and the starter violently cranks the engine back to life, metal is grinding directly against metal for a critical microsecond before oil pressure can be reestablished. Over 100,000 miles, a standard engine might experience 50,000 start cycles. But an auto start-stop engine undergoes 500,000. You are actively cooking your engine bearings to satisfy a regulatory fleet average fuel economy quota. To make matters worse, this constant cycling severely degrades your starting and charging system. Every restart pulls massive amperage from your battery, forcing the alternating current generator to run at maximum duty cycle to replenish the loss, which prematurely cooks the internal diodes and wears out the starter motor brushes 3 times faster than a traditional setup. You can manually press the deactivation button on the dash every time you turn the key, but Ford purposefully engineered the software to reset to on every single time the ignition is cycled. To permanently save your bearings, you have to plug a diagnostic scan tool into your OBD2 port, access the central configuration matrix via software like ForScan, and disable the auto start-stop feature at the factory level, or install a physical hardware bypass module behind the switch bank that remembers your preference. Then there is the factory transmission shift logic, specifically on the 10R80 10-speed automatic transmissions found in almost every modern Ford truck. To chase microscopic fuel economy gains, the factory programming forces the transmission to skip gears under light acceleration, frequently shifting straight from first to third and then third to fifth, while keeping the engine RPMs dangerously low, often hovering right around 200 RPM under load. This low RPM, high load condition is known as lugging the engine, and it creates massive cylinder pressure that places immense stress on the piston rings and wrist pins inside the transmission itself. This skipped gear strategy forces the internal clutch packs to slip excessively to smooth out the massive ratio jumps, creating extreme localized thermal spikes that degrade the transmission fluid and accelerate the wear of the delicate friction materials. I have torn down dozens of these 10-speed units with less than 60,000 miles on them, only to find the fluid burnt black and the valve body bores scarred from the debris generated by this exact factory shift strategy. Switching your vehicle into tow haul or sport mode every time you drive forces the transmission control module to utilize every single gear sequentially, keeping the engine in its optimal power band and saving your clutch packs from an early grave. But it is a temporary fix for a deep-seated programming flaw. We have only scratched the surface of how these factory configurations are actively working against the longevity and security of your vehicle. And there are several more critical hidden settings inside your truck's computer system that you need to alter immediately before they cause catastrophic, irreversible damage. We just uncovered how Ford's factory keyless entry configurations leave your driveway vulnerable to silent electronic intrusion, and how the auto start-stop settings are actively starving your crankshaft journals of critical lubrication. Those vulnerabilities are severe, but they are completely eclipsed by the hidden setting we are stripping down right now. If auto start-stop is a slow grinding rot, this second factory configuration is a high-speed, catastrophic sledgehammer aimed directly at the heart of your engine's cylinder head. I am talking about the factory-programmed extended oil change interval, coupled directly with the ultra-low viscosity fluid requirements and the oil bath timing belt configurations inside modern Ford engines. Walk into any dealership showroom today, and the sales team will proudly point to the vehicle's intelligent oil life monitor. The factory software configuration is calibrated to tell you, the owner, that your engine oil is perfectly fine for 10,000 miles, or sometimes even up to 12,000 miles, before requiring a service. It sounds incredibly convenient, and it lowers the advertised cost of ownership on paper. But as a technician who has spent more than 15 years knee-deep in metal shavings and ruined blocks, I can tell you that this single programming choice is the most destructive setting on your vehicle. It is designed to get the powertrain past the factory warranty period, after which the financial fallout is entirely your problem. Let me explain the brutal mechanical reality of what is happening inside that crankcase while you blissfully drive 10,000 miles between service bays. Modern Ford engines, particularly the EcoBoost lineup, utilize high-pressure direct fuel injection, because the fuel is sprayed at up to 3,000 pounds per square inch directly into the combustion chamber, rather than over the intake valves. A significant amount of microscopic fuel droplets blow past the piston rings during the compression stroke. This process is called fuel dilution. When gasoline mixes with your engine oil, it fundamentally alters the fluid's chemistry. It strips away the oil's shear stability and slashes its viscosity. Ford already specifies an incredibly thin fluid from the factory, often a 0-20 or 5-20 weight oil, in an effort to reduce parasitic mechanical drag and squeak out an extra fraction of a mile per gallon for regulatory compliance. When you combine an already paper-thin oil with a massive dose of raw gasoline dilution over a 10,000-mile interval, that fluid ceases to act as a lubricant. It turns into a watery, highly corrosive solvent. Just last month, a 2021 Ford SUV was towed into my shop with 63,000 miles on the odometer, just 3,000 miles out of its factory powertrain warranty. The owner was meticulous about following the dashboard prompts. She never missed an oil change, according to the factory Intelligent Oil Life Monitor, which consistently allowed her to drive around 9,500 miles between service appointments. The engine was making a violent metallic slapping noise from the front cover before it finally seized on the highway. When I pulled the front timing cover off that engine, I didn't find clean components. I found total mechanical devastation. This specific engine architecture uses what Ford calls a wet belt system, a rubber timing belt that runs completely submerged in the engine oil to reduce mechanical noise and friction compared to a traditional steel chain, because the factory oil lift E-monitor allowed fuel-diluted, highly corrosive oil to sit in that crankcase for nearly 10,000 miles at a time. The raw gasoline in the oil chemically attacked the rubber compounds of the timing belt. The belt had literally dissolved from the inside out. The friction backing of the belt had sloughed off into the oil pan, creating a thick, fibrous sludge that completely clogged the oil pump pickup screen. The oil pump, starved of fluid, began cavitating, dropping oil pressure to near zero. Without oil pressure, the hydraulic timing chain tensioners collapsed. The dissolved belt jumped 3 teeth on the camshaft sprockets, and the pistons slammed directly into the intake valves at 70 miles per hour. A perfectly maintained vehicle, according to Ford's own dashboard settings, was transformed into a $9,000 pile of scrap metal because the factory software lied to the owner about the condition of the lubricant. This chemical rot doesn't stop at the timing belt. When your oil is sheared down to the consistency of water by extended factory intervals, it loses its ability to protect the variable camshaft timing phasers. These phasers rely entirely on hydraulic oil pressure to advance and retard engine timing on the fly. When the oil thins out and becomes contaminated with carbon soot and raw fuel, the precision machine tolerances inside the phasers wear out prematurely. You'll start noticing this as a harsh, 1-second metallic rattle upon a cold start in the morning. That rattle is the sound of the internal locking pin violently slamming against the phaser housing, because the watery oil has drained completely out of the unit overnight, leaving dry metal to smash against dry metal until the oil pump can catch up. By the time the dashboard check engine light finally illuminates for a timing misalignment, the camshaft journals are already heavily scored, and the engine is on borrowed time. The fix for this is incredibly simple, but it requires you to completely ignore the vehicle's factory prompts. You must manually override the manufacturer's narrative. First, flash adjust your service habits. Throw the 10,000-mile interval out the window and dump that oil every 5,000 miles or 6 months, without exception. If you do a lot of short-trip driving or idling, drop that number to 4,000 miles. Second, if you own a Ford engine utilizing a wet belt configuration, you must ensure that whoever changes your oil is using a specific fluid that meets Ford's strict WSS M2C948B or equivalent material standards, which contain specific additives designed to resist rubber degradation. Standard off-the-shelf motor oil lacks these specialized compounds and will accelerate the dissolving process. Finally, do not rely on the dashboard percentage indicator to tell you when to open the hood. Manually pull the dipstick every 2 weeks and smell the oil. If the fluid smells strongly of raw gasoline or runs off the metal stick like water, it is spent. Regardless of what the factory computer screen claims, the underlying truth of modern vehicle ownership is that the engineers who built your truck know exactly how thin these margins are, but their hands are tied by corporate mandates to meet strict environmental and marketing targets. The factory settings are optimized to make the vehicle appear eco-friendly and low maintenance on a spreadsheet, not to ensure it runs for 300,000 miles. By leaving these systems at their default parameters, you are actively participating in the premature wear of your own powertrain. You have to take the administrative control away from the factory programming and implement a rigorous, old-school mechanical maintenance schedule if you want to protect your investment. We have exposed the electronic vulnerabilities that invite thieves in and the lubrication traps that destroy your internal components from within. But there is still a massive, hidden flaw lurking in the electronic braking and traction control configurations that can cause total mechanical lockup while you are traveling at highway speeds. We have already pulled back the curtain on how Ford's factory proximity signal settings leave your truck completely exposed to neighborhood relay thieves. And we strip down the brutal reality of how extended oil change intervals and watery factory fluids chemically dissolve internal components from the inside out. Those two vulnerabilities are devastating, but this final factory configuration is the most deceptive of them all. It is a hidden digital calibration built directly into the anti-lock braking and stability control modules that can cause a sudden, violent mechanical lockup of your rear axle while you are moving at highway speeds. I am talking about the electronic brake force distribution and automated roll stability control factory default settings. When you buy a modern truck or SUV, you assume that the traction and braking systems are engineered solely to keep you straight and level on the road. That is the marketing narrative. But in the service bays, we see the dark side of how these modules are programmed. In an effort to make heavy, high-profile utility vehicles handle like sports cars on dry pavement, the factory calibration utilizes a highly aggressive strategy called asymmetric brake vectoring. The vehicle's stability module is constantly monitoring steering wheel angle, lateral G-force sensors, and individual wheel speed sensors. The moment the software detects even a microsecond of body roll or slight handling imbalance during a high-speed lane change or an emergency maneuver, it commands the hydraulic brake actuator to independently apply the rear brakes, without you ever touching the brake pedal. Here is where the engineering compromise turns into a catastrophic mechanical failure. Because this system operates silently and completely in the background, you have no idea it is happening while you drive. The software is designed to apply rapid, high-pressure pulses to the rear brake calipers to drag the inside wheel and force the vehicle to pivot smoothly through a turn, under the extreme heat and constant pressure cycles of highway driving. This aggressive factory calibration causes the rear brake pads to drag continuously against the rotors. This continuous friction creates a massive thermal bottleneck. The heat transfers directly from the brake rotor through the hub assembly and straight into the rear axle tubes, severely cooking the thin, factory-filled differential fluid and destroying the outer wheel bearings. I recently had an F-150 towed into my shop that perfectly illustrates this hidden design trap. The owner was cruising down the interstate at 70 miles per hour on a clear, dry afternoon. He hadn't been towing, and he hadn't been riding the brakes. Suddenly, the left rear wheel locked up completely, sending the truck into a violent skid across 3 lanes of traffic. When I tore down that rear end on my lift, the root cause was glaringly obvious. The factory stability software had been aggressively dragging that left rear brake to compensate for a slightly worn leaf spring bushing that was causing minor body roll. The localized heat generated by that constant automated braking application had reached over 800 degrees. It completely vaporized the gear oil inside the outer axle bearing housing, turning the lubricant into a black, tar-like crust without lubrication. The roller bearings experienced total thermal welding. They literally melted and fused directly to the steel axle shaft in a fraction of a second, causing an instantaneous, unyielding mechanical lockup at highway speed. The factory safety software designed to keep the vehicle stable had literally engineered its own catastrophic mechanical failure. To make matters worse, this silent braking application places an immense thermal load on your entire brake system, causing the rear brake pads to wear out 3 times faster than the fronts, which completely reverses traditional mechanical wear patterns. Owners constantly bring their vehicles in for routine service, completely baffled as to why their rear brakes are completely ground down to the metal backing plates at 25,000 miles while the front pads look brand new. The service advisors will tell you it's just normal wear and tear for modern electronic systems. But they are omitting the fact that the factory software is driving your vehicle with the brakes parking braked on your behalf just to mask inherent AS's dynamics. Now that we have stripped back all 3 of these hidden factory traps, you need to understand that they are not isolated flaws. They are part of a cohesive design philosophy that prioritizes short-term consumer perception over long-term mechanical survival. The manufacturer configurations are optimized to deliver a silent cabin, a car-like ride, a low advertised cost of maintenance, and seamless keyless entry during the initial dealership lease period. They are counting on the fact that when the key fob relay vulnerability results in a stolen truck, or when the extended oil interval dissolves your timing belt, or when the automated stability logic welds your axle bearings, the factory warranty will have already expired, leaving you with a multi-$1,000 repair bill. You have to break this cycle by taking administrative control of your vehicle's computers and changing how you maintain the physical machine. To defeat the electronic threats, you must isolate your keys in a verified Faraday pouch every single night, and immediately program a push-button start pin directly into your sync touchscreen settings to ensure that an uninvited cabin guest cannot crank the engine, to halt the chemical destruction of your internal powertrain components. You must explicitly reject the 10,000-mile dashboard prompt, drop your oil change intervals to a strict 5,000-mile limit, change your transmission fluid every 40,000 miles to purge the debris from skipped gear factory shifting, and completely disable the bearing-starving auto start-stop feature via diagnostic software. Finally, to protect your rear axle assembly from the thermal overload of automated brake vectoring, you must regularly inspect your rear brake temperature and pad wear, service your rear differential fluid every 30,000 miles with a high-quality synthetic gear oil that can handle extreme thermal spikes, and utilize your vehicle's Talbot Hall or manual mode configurations during heavy driving to alter how the stability module distributes chassis load. The responsibility for the physical survival of your vehicle has been quietly shifted directly onto your shoulders. The tools and settings to protect your truck are entirely within your grasp, but you have to actively override the factory parameters to implement them. Take control of your machine this weekend. Buy the pouch, set the start pin, drop your oil change intervals, and inspect those rear brakes. If this insider teardown helped you understand what is actually happening beneath the sheet metal of your vehicle, take a second right now to hit that like button, subscribe to the channel, and share this information with another owner who is blindly